today it is the properties of carbon and silicon. So carbon and silicon, these two elements are mainly from the group 4A, as all have the 4 electrons in their valence shell. The atomic number of carbon here we have it is 6, and for silicon its atomic number we have 14. As the electronic configuration for carbon we have 1s2, 2s2, 2p2, and for silicon its electronic configuration we have 1s2, 2s2, 2p6, 3s2, and 3p2. From their electronic configuration we can see that all they have 4 electrons in their valence shell, so that's why the valency of both carbon and silicon will be 4. And here in this picture you can see that in the center here we have the carbon, and it is combining with the 4 silicon atoms. So we can see Si4. It's mean we have just 4 silicons with the carbon, as carbon is a central atom. On the other hand, here you can see that we have this is the silicon, and there are the 4 carbon atoms attached to it. So the structure we have SiC4, silicon carbide. In this way, the carbon and silicon can also make the bond with one another and changes into the structure. That structure we call it as the tetrahedral structure, as both having the valency of 4, so they can make 4 bonds with one another to make a stable structure. Next, we have the occurrence of carbon and silicon. That where does the carbon and silicon are found? The first one we have carbon. Mainly carbon, it is the naturally occurring substance and it occurs in mainly two states. One of its state we have graphite, and the other we have its state is diamond. It is the occurrence of carbon. It is present in nature. So here you can see that this is the carbon. As it is having its crystalline form, and the other we have its amorphous form. In the amorphous form we have its coal, and we have charcoal. So these are the naturally occurring forms of the carbon. On the other hand, we have also the minerals of the carbon. The first one we have is limestone. Limestone. Its formula we have is basically calcium carbonate, CaCO3. So here the carbon is present. Then we have its other dolomite. In the dolomite form, it is the magnesium carbonate plus or dot with the calcium carbonate. And the third one form we have, it is the magnesite. And the magnesite is basically the magnesium carbonate, MgCO3. So this is a simple occurrence of the carbon. After that we have the occurrence of the silicon. When we have a look on the silicon, it is very abundant, and about silicon, it is about 25% of the mass of the earth crust. It is too much, or it is very abundant in nature. As it is very abundant in nature, so silicon, it is unlike carbon, it is not found in free state. It is always found in the mineral form, and we have also a lot of minerals of the silicon. The first one we were having the zeolite. As the zeolite, it is a mineral of silicon in which we have sodium aluminium silicate along with the one water molecule, so it is monohydrated zeolite. Then we have asbestos. Asbestos is also the mineral of the silicon. Formula we have calcium magnesium silicate. So, along with zeolite, asbestos, we have is zircon and talc. So, silicon, it is present not in the free state, but we have its mineral forms. This is a simple occurrence of the silicon and carbon. After that, we have the similarities and differences of the carbon and silicon, that how they are similar and how they are different from each other. First one, similarity is they are similar in nature. Their nature is same. They are present in the solid state. Then they are tetravalent. Tetra mean four and valent mean valence shell. They have four electrons in their valence shell. So if I'm going to draw here the carbon, it is having two shells, and here we have silicon. It has three shells, and when we have a just look on their electrons, so this is for silicon, its second shell contain 8 and the outermost shell contain 4 electrons. On the other hand, again for the carbon, 2 electrons in the first shell and the 4 electrons in the valence shell. This is for carbon and this is for silicon. They have allotropic forms. The allotropic nature is similar both in carbon and silicon. They can burn in the presence of oxygen. They have covalent hydrides. It means they can combine with the hydrogen and changes into the metal hydrides. They have similar halides. Halides mean they can make the halides. For example, we have silicon chloride and here we have carbon tetrachloride. So this is a simple chlorides that are similar in nature. Let's move to the differences between the carbon and silicon. So the first difference between carbon and silicon, we have it has two electrons, 8 electrons into the penultimate shell. It has two electrons and it has total 8 electrons in the penultimate shell, is the shell next to the valence shell. As the carbon, its electronic configuration is 2, 2 and 2, and for the silicon we have 2, 8 and then 4. So this is a simple electronic configuration change. Then one is the black solid and the other is reddish brown solid. Then the catenation in one carbon is strong and it is catenation process in silicon that is weak. The carbon has no effect of alkali, aqueous and fused alkali in the presence of hydrogen, but the silicon have. Then we have covalency. The one can make the four bonds, other can make the six bonds. On the other hand, here chlorides, or we can say that halides. CCl4 it is stable, but the silicon chloride is less stable. So these are some differences between the carbon and silicon. I hope you guys understand about some properties of the carbon and the silicon. And if you have any queries, you may ask me about that in the comment section. The next topic that we will discuss, it is the peculiar behavior of the carbon, as carbon is the first member of the group 4A, how it is differentiated from the other group members. For that time, you guys keep learning and have a good day.